Alright, so welcome to the first video for Math 101. We're working on Chapter 1. Okay, so real quick, mention on my notes, you'll see the chapter up here, and then the section we're working on in bold and underlined right above. Alright, and all of these sort of important definitions and pieces of information will be in these little blue boxes. So real quick, some vocabulary. When you're looking at a fraction, the numbers on the top are called the numerator, and the numbers on the bottom are called the denominators, or just the value on the bottom is the denominator. So, when we're looking at fractions, there are three different sort of, outcomes. So, if the numerator, remember, the number on the top, if it is smaller than the denominator, then our fraction has a value less than 1. For example, a half. Is that less than 1? Yeah, and if you'll check, the numerator value is indeed smaller than the denominator. So another option, if the numerator is bigger than, the denominator, the fraction has a value greater than 1. Let's look at an example. 3 halves. Okay, 3 halves, which is actually the same as 1 and a half, that is bigger than 1. Next one, if the numerator is the same as, if the numerator is the same as the denominator, the fraction has a value equal to 1. Okay, what would an example of that be? 3 over 3. 3 over 3 is the same as 1. If the number on the top and the bottom are the same. Another example for that would be maybe 5 over 5, which is also 1. All right. Example 1. Okay, so identify if the fraction is less than, greater than, or equal to 1, and state your reasoning. Okay, so we're going to use this information above. So let's take a look. For this fraction, the top number is bigger than the bottom number. So that is this option here. If the numerator is bigger than the denominator, the fraction has a value greater than 1. So this value is greater than 1 because I'm just going to go ahead and use n for numerator and d for denominator because the numerator is greater than the denominator. Okay, so n for numerator, d for denominator, using this equal sign, greater. If you sometimes have a hard time memorizing this, think of that opening as like the Pac-Man mouth. The Pac-Man goes for the bigger item, and in this case, the numerator was bigger, so the Pac-Man's going to eat the numerator. All right, to go ahead and try B and C by yourself, pause the video, take a try at that, and get back to me in a second. All right, so I'm assuming you pause the video and try these yourself. So let's see, the numerator in this case is smaller. So I know this is going to be less than 1 because the numerator is this time less than the denominator. And the last one, notice they're both 5s. So that's the last option, which is this is equal to 1. Equal to 1 because the numerator is equal to the denominator, or the same as the denominator. All right, so next part, improper fractions. All right, so what are these? Improper fractions are fractions where the numerator, remember the top number, is a bigger number than the denominator. Okay, that is what we would call an improper fraction. Sorry if the video keeps whacking in and out. My table isn't the most stable table. All right, so example 3. Which of the following are improper fractions? So what are we looking for? We're looking for the number on the top to be bigger. This one, the number on the top in the numerator is smaller. So this one, it's not an improper fraction. This one, oh, look, the bigger number is on the top. So that is going to be an improper fraction. And the last one, the bigger number is also on the top. So for this one, sorry, the bigger number was on the bottom. So this is going to be improper fraction. improper fraction. So what would we call the first one? The first one is a proper fraction. Okay, so mixed numbers. All right, fractions with a value that are greater than 1. So for example, this value here, 3/2, that was a value greater than 1. So fractions with a value greater than 1 are more properly written as mixed numbers. Okay? So this is considered improper. So to make it proper, we would write it as a mixed number. And what is a mixed number? Well, a mixed number combines a whole number with a fraction. For example, as I did before, 3/2, that is improper because the number on top is bigger. I can rewrite that as 1.5, and we'll go over how to do that in a sec. All right, so first though, we're going to write out how we would read the following mixed numbers. So remember, how do I know these are mixed numbers? They're mixed numbers because they have two parts. They're mixed. I got a fraction and a whole number. So it's a mixing of two different types of numbers. Same thing, is this a mixed number? Yes, because I have a, I have a whole number and a fraction. So how would we read these? Well, this is going to be, you start with the whole number part, 2, and then in between this, normally, actually, this number 2 2/3 is the same as if we wrote 2 and 2/3. So most of the time we just leave out the plus sign, shorthand writing. So this is 2 and 2/3. Okay, so write out how we would read part B. All right, so B would be 3. You start with the whole part. 3 and 4/5. I hope that's how you spell fifths. All right. Okay, not too bad on that part. Hopefully, this is just a good part of review, and if not, it's a good time to catch up on it. All right, so next page, 2 of 2 for this. So we're still working on 1.1. All right, converting mixed numbers. So to convert an improper fraction into a mixed number, our plan, divide the numerator by the denominator, then take the remainder and write it as a fraction with the remainder as the numerator over the original denominator. A lot of words, probably a little hard to grasp, so we're going to go ahead and do an example. So B, what are we doing? Well, we're going to do the division first. So remember, as a fraction, this is actually just division. So writing this out as a division problem, we got 3 and 11. A way I remember it, if it's hard to remember who goes in the house, let's say if 3 was standing under the roof, this is the roof right here, 11 is so big and so heavy the roof can't hold it, so 11 is going to fall through the roof, and if 3 is smart, 3 is going to run outside. Okay, so that's what happened here. 11 fell through, 3 ran outside. I don't know, just a sort of funny way to remember it. That's how I remembered it. All right. So let's see, how many times can 3 go into 11? 3 times. Oh, that was supposed to be a different colored pen. Wait, let me use my 3 times. There we go. And then let's see, 3 times 3 is 9, so we're going to do the subtraction. 9, 10, 11, 2. All right, so our remainder is 2. So what we're going to do is take this 3 value here and write it in the front. So 3, that's the whole part. And then we'll take our remainder. Oh, sorry, not that 3. I don't know why I grabbed that 3. Wrong 3. This 3 right here is the one we're grabbing. Too many 3's floating around. This 3, that's going to be 3, and we'll take our remainder, the 2, and write it as a fraction as the numerator over the original denominator, which was the value we were dividing by, that 3. All right, so let me rewrite this so it's not a bunch of colorfulness. 3 and 2/3. Okay, so this was an improper fraction, and now we wrote it as a mixed number, which is the proper way of writing it. Okay, so we'll go ahead and do this one together, and then I'll ask if you can pause the video and try C by yourself. So, rewriting this as a division problem. 6 can go into 25. How many times? 4. That's the closest it can get to 25. So doing that subtraction, that's going to be, well, 6 times 4 is 24. Do the subtraction, that's going to be 1. So our answer will be 4 and 1/6. The remainder went under the leftover fraction, and there we go. Okay, go ahead, pause the video, try C by yourself. All right, so for C, let's check your work with mine. 8 can go into 20. How many times? Let's see. 8 times 2 is 16. 8 times 3 is 24. Okay, so the closest we can get is 8 times 2. Okay, doing that subtraction. 16. It's going to be 4. So our answer will be 2 and 4/8. And we can actually simplify this, but for now, we're just going to leave it because I'm going to show you how to do the simplifying in a few more sections ahead. Okay, so for now, it's okay. All right, so we're going to do the exact opposite now. So for example 4, we're going to convert from the mixed number into an improper fraction. So we're going to go the exact opposite way. So how do we do this? First, you multiply the denominator to the whole number, and then you add that value to the numerator. Okay, and then we take that result as the new numerator over the original denominator. Whew. Once again, a lot of information. So let's go ahead and do an example. 4 and 2/3. So the plan. First, we will multiply the 3 times the 4. And then whatever that product is, we're going to add it to 2. So let's see. 3 times 4 is 12. And then we're going to add 2 to 12, and we get 14. So this is just some scratch work real quick here. So 14 is my new numerator. Okay, so we have 14/3 is our improper fraction. Okay. So real quick, for this one, let's do a fun check to see if we're right. So let's turn this into a mixed number, like what we were doing above. So to do that, remember we do the division. 3 can go into 14 how many times? 4. Doing that subtraction, we get the leftover of 2. So our answer is going to be 4 and 2/3. Is that the original fraction we were working with? Yes, it is. All right, so we did our work correctly. This was the check. Awesome. All right, so B. Go ahead and try B and C by yourself, and then check back in with me. All right, so let's rewrite this a little bigger. So we do the multiplication here, so that's going to be 2 times 6, which is going to be 12, and then plus 5. Let's write that out. 12 plus 5, which is going to equal, what is that, 17? So our new fraction is going to be 17 over the original denominator, 6. And you could check your work to make sure you were right, just like how we did on this one. And C, let's rewrite this again. And do the multiplication. So 1 times 8, and then add the 3. So 1 times 8 is going to be 8. Adding 3 is going to be 11. All right, so my fraction is going to be 11/8. So this is the mixed number, and this is the improper fraction, and that was the original mixed number. 1.2, we're moving on. So equivalent fractions have the same value even when they are written differently. Okay, so equivalence basically means that they are worth the same, but they don't look the same. All right, so for example, an equivalence that you might think of would be 4/4 is the same thing, so it's equivalent 2, what is 4/4 equivalent to? Well, one example would be $1. Oh, sorry, got that switched around. The dollar sign should be on the other side. But this is an equivalence. A dollar bill is equivalent to 4/4. Even though they don't look the same, they still have the same value. So that's what we're looking for. Fractions that are equivalent even though they don't look the same. So we want to create 3 equivalent fractions for a third. How do we do that? Well, what you do is you're going to play around with some multiplication using the building up property. So let me do this. Building up property. Basically, it is as I shall show you. So, to create an equivalent fraction, just think of a random number you want to multiply to 3. Could be anything, 2, 5, 10, 100, -3, any number. I'll just go with 2. Let's stick to the small things. So I'm going to multiply the denominator by 2. And then, using the building up property, I have to, now here, notice please, you have to balance that out and multiply the top by the same number. So that is going to equal, well, when we're multiplying fractions, you multiply across the top. That's going to equal 2 over, multiplying fractions, multiply across the bottom, 3 times 2, 6. So there we go. There is one equivalent fraction for a third. Let's try another equivalent fraction. So we already multiplied by 2s. Why not let's do 3s? Okay, so multiplying that, we're going to get 1 times 3 is 3. 3 times 3 is 9. Aha! Another equivalent fraction for a third. Go ahead and create one more equivalent fraction. I'll go ahead and use 10. And there we go, another equivalent fraction. All right, so I'm going to set up, I'm going to do the first one, and then I'll set it up for you and have you work on this. So, equivalent fractions for 5. Well, you might say, gosh, 5 is not a fraction. But, remember, with whole numbers, you can create it into a fraction by just writing it over 1. And there you go, 5 is now a fraction. How handy. Okay, so I'm going to create, let's see, to create this into an equivalent fraction, let's multiply top and bottom by 5. Okay, go ahead and see what you would get for that. Okay, it's going to be 25 over 5, another equivalent fraction. And 5 over 1, let's do, what are we going to times that by? How about 6? Okay, that's going to be 30 over 6. And then one more equivalent fraction. Why not? Let's be fun and pick some huge random number. Let's go with 100. Why not? So 500 over 100. So notice this number, and this number are all equivalent fractions for 5. And just as this number, and this number are all equivalent fractions for a third. They may not look alike, but they all have the same value. Just like 4/4 does not look like $1, but if you went to the store to buy something that was $1, the person would accept either the 4/4 or the $1 because they have the same value. All right. So creating 3 equivalent fractions for, a mixed number. Okay, so with a mixed number, if we want to create an equivalent fraction, first we want to turn it into a improper fraction. So let's do that before we do anything else. Let's see how to do that. We're going to multiply and then add. So that's going to be 3 plus 2, 5 over 3. So there we go. That is our fraction 5 over 3. Okay, so I'm going to set up creating the equivalent fractions. There are really very few restrictions to this because there's so many numbers in the world to use. Let's say, okay, I'm going to set these up for you. So go ahead and when I write this down, write out the answers and then check back with me in a little bit. to see what you got. Okay, so I've set it up for you and asked you to create the equivalent fractions using these numbers. Alright, so let's see what this would be. That's going to be 5 times 3, 15. 3 times 3, 9. There's an equivalent fraction. 5 times 4, 20. 3 times 4, 12. Another equivalent fraction. 5 times 5, 25. 3 times 5, 15. And there we go. Equivalent, equivalent, equivalent. And we're good. So if you need some help practicing multiplication times table, you can always send me an email and I'll see if I can send you a resource for practicing your multiplication table. Because I think I mentioned it, maybe not. For Chapter 1 and Chapter 2, you need to do everything by hand, no calculator allowed. So just basic calculations in your head for Chapter 1 and 2. Alright, so a new idea. Cross multiplication. Alright, when you have two fractions that are equal to one another, like this, you can multiply the numerator of the first fraction, numerator of the first, with the denominator of the second. And then multiply the denominator of the second fraction with the denominator of the first. So notice it looks like a cross or an X actually. And why do we use this? Well, this is if you're trying to solve for X. Okay, so see our little X value up here? We're trying to get X by itself. That's what it means to solve for X. We want to get X by itself on an equal sign. So to do that, let's use cross multiplication. So 2 times 15, which maybe you do know that off the top of your head, maybe you don't. Let's go ahead and multiply that out. So 15 times 2. It's going to be 2 times 5, carry the 1, so it's a 10. And then 2 times 1 is 2, plus 1 is 3, so the answer is 30. So 2 times 15 was 30. Carry down the equal sign. And then x times 5, which I can't actually do, so that's just going to be 5x. Where's my green? All right. Okay, they rewrite this in black. All right, we need to get x by itself. So x is being multiplied by the 5. So to undo multiplication, we're going to use the opposite of multiplication, which is division. Divide by 5. So 5 divided by 5 is 1. Then we have to divide the other side by 5. Remember, you have to balance out the equation. So 30 divided by 5 is 6.